Hello everyone, and welcome. In 2026, astronomers detected a very strange radio signal coming from outer space. A signal that appears suddenly, then disappears for 22 minutes, and then appears again continuously without stopping. But that's not even the strangest part. The weird thing is that when they reviewed the records of detected signals, they found that telescopes in 1988 had detected a strange signal that also repeated every 22 minutes with no explanation. And since '88, several telescopes have detected the same signal over the years, and this signal is still ongoing until the moment you're listening to this right now. That means it's been more than 35 years repeating with a fixed and very strange pattern. Welcome, I'm Amr Abedin, but before we start, if you're new to the channel, don't forget to subscribe and turn on notifications so you get our videos first. The story begins at the MWA Astronomical Observatory located in Western Australia in the Wajarri region, which is a massive radio telescope, but not just one telescope in number. The observatory consists of 4,000 receiving antennas, all connected together, forming a massive network that detects waves coming from space with frequencies ranging between 70 MHz to 300 MHz. The main goal of building this telescope was to study Earth's ionosphere, study the Sun, and help map the sky through radio waves and monitor distant stars and galaxies. From the moment of its launch in 2013 until now, it has collected tens of petabytes of data that are stored at the Computing Research Centre in Perth, Australia, so that later researchers from all over the world can access and analyze this data. The point in this matter is that in 2026, a research team from Curtin University received through this observatory a very strange radio signal coming from the direction of the Scutum constellation, from a location about 15 to 18,000 light-years away from us. What's strange about the signal is that it resembles fast pulses, appearing and disappearing and appearing and disappearing at a steady rate. When they measured its repetition time, they found it repeats every 22 minutes. When they detected this wave for the first time, they directed all their telescopes toward the location emitting the wave to monitor it intensively, and they searched all the data and archives of old telescopes that had monitored this location before. For example, they searched the records of the Very Large Array Telescope located in New Mexico, USA, and also searched the Giant Meter Wave Telescope in India. The surprise was that they found data for the same wave recorded from many years ago, starting from 1988 until 2026 when they detected the wave themselves. What's even more remarkable is that these archival records showed that over all these years, the wave was repeating at the same rate without changing even by 1 second, repeating every 1,318.1957 seconds exactly, and the number doesn't change. For the research team to determine what object is sending this strange signal, they put forward a set of possibilities. The first possibility is neutron stars. Neutron stars are extremely dense objects containing billions of tons of matter in a very small space. They emit radio waves and light rays from their poles, and because of their rapid rotation around their axis, the waves they emit rotate exactly like a lighthouse. That's why their waves can reach us as pulses that appear and disappear. Well, that's a good explanation. So is the signal coming from a neutron star? What makes neutron stars emit radio waves is their rapid rotation. Their rapid rotation creates a magnetic field around the star, and the magnetic field helps accelerate charged particles at the poles. And after a complex process, radio waves are generated. So where's the problem? The problem is that the object emitting the signal that researchers received is a very slow object. We just said a moment ago the signal repeats every 22 minutes approximately. So if it's really a neutron star, that means it's rotating around its axis every 22 minutes, and this would be unlikely for two reasons. The first reason is that neutron stars rotate around their axis at a tremendous speed. They can complete one rotation in 1 second, and sometimes even less than a second.
The second reason is that if we assume there's a neutron star this slow, this star wouldn't produce radio waves at all, because as we said, the reason for radio wave generation is the star's rapid rotation. Therefore, it can't be a neutron star and must be something else.
And this takes us to the next possibility, which is magnetars. There's a type of neutron star that has an extremely high magnetic field with a strength reaching 100 billion Tesla, meaning approximately 100 times stronger than the magnetic fields of regular neutron stars. And these stars are known as magnetars. What's special about these stars is that they rotate around their axis slowly compared to regular neutron stars. But despite this, they produce large amounts of radio waves due to their high magnetic field. That's why a group of researchers predicted that this signal source could be a magnetar. But this possibility is also uncertain, especially since magnetars emit large amounts of X-rays along with their waves, as well as some gamma rays. And this is a characteristic found in all magnetars without exception. When researchers directed their telescopes toward the location where the signal is coming from, they found no trace of X-rays at all, only radio waves. Add to that, magnetars generally have radio emissions that continue for a few months or a few years at most, and then the star loses its energy and these radio waves disappear, while the source we're talking about has been sending the signal for 35 complete years, if not much longer before that. Therefore, the possibility that the signal source is a magnetar is also a weak possibility. To get out of this dilemma, researchers suggested that the signal source could be a white dwarf. White dwarfs are formed when giant stars run out of their fuel. When giant stars reach the end of their life and their energy runs out, they lose their outer layers and only a small, dense core remains that emits white light, which has been described as a white dwarf. These white dwarfs are characterized by rotating slowly compared to regular neutron stars, and their rotation period is usually in minutes, not seconds. This means it could actually be a white dwarf rotating around itself in 22 minutes. A strong candidate. Unfortunately, there's still a problem. For a radio signal to reach us from a white dwarf with the same nature as the signal we're receiving, this dwarf needs to have a tremendous magnetic field. But astronomers over all the past years have never encountered a white dwarf with such a massive magnetic field before. Therefore, the probability of it being a white dwarf is also a weak probability. So now, what's left? I know what you're thinking right now. Could this signal be coming from intelligent beings, aliens trying to communicate with us? This question was asked to the leader of the research team in charge of the project, and she answered it in an article she wrote. I know the topic of aliens is tempting for people, but let's not pin our hopes on this subject. She gave an example, saying that in 1967, when we discovered the first pulsar, its signal was very strange to researchers at the time. They didn't understand what it was, to the extent that people named it LGM-1, which was short for Little Green Men 1, because a large group of them believed that a group of aliens were sending us these signals. But it later turned out they weren't aliens or anything. It was a neutron star. That's why she said, let's not make general judgments about the signal until we reach clear evidence, especially since when they analyzed this signal, no information appeared with them, just noise similar to natural radio sources, which confirms that whatever the nature of this object is, it will undoubtedly be something strange we've never seen before. Until this moment, they're still searching in every possible way for the source emitting this strange signal, and all we can do is wait for the coming months or years. Maybe new evidence will appear that helps us understand this signal. That's it. We're done. Who made it to the end? Everyone who made it, you're the best. Give us a like before you leave so we know how many reached the end. And don't forget, if you have a video suggestion, write it in the comments. Most of the episodes we make now, we get them from your comments. Peace out.